Okay, so welcome to this tutorial. In this tutorial, we're going to go through the IEB physics paper, the supplementary exam from 2015. So in this first video, we're just going to go through the MCQ, so question 1.1 till question 1.10. Okay, so when we're doing this, I'm going to go through the correct answers, and then for certain questions, I'll explain why the other answers are incorrect, just so that you know. And then I suggest that you read these questions, pause the video and do the question, and then follow and see if you got the answer correctly. Okay, so let's start with question 1.1. So the question asks for two vector pairs, to find the two vector pairs. So first we need to know what a vector and what a scalar is. So a vector is a physical quantity that has both magnitude and direction. It needs to have these two things. The opposite of this is a scalar, which only has a magnitude. So let's go through our options. So work and power, both of these are scalar. So therefore we can't have A as an option. Let's try distance and displacement. Distance is a scalar, while displacement is a vector. So once again, this can't be our answer. Momentum is a vector and force is a vector. Therefore C would be the correct answer. If we look at the last option, we have acceleration, which is a vector, and we have time, which is a scalar. So we can see that C is the only correct answer. Let's look at this graph now. It says the shaded area represents the objects, and we've got a velocity time graph. So the shaded area is this area. So to figure this out, the area of this would be half base times height. So how we're going to figure out the answer is we're going to use dimensional analysis. So we're multiplying our base, which is time, by the height, which is the velocity. So what dimensions do time and velocity have? So time is in seconds and velocity is in meters per second. So when you multiply these two, the seconds cancel, giving us units of meters. Therefore, it can't be acceleration. It is displacement, so the answer is displacement. Acceleration is meters per second to the -2. So you can't have acceleration. Displacement has units of meters, and therefore displacement is the correct answer. Let's look at impulse. Impulse, the units are kilograms meters per second. So again, that can't be the answer. And the average velocity is in meters per second. So that again is not the answer. So our answer is B. Okay, so question 3. A book rests on a table. According to Newton's third law, what is the reaction force to the weight of the book? So first let's understand what the weight of a book is. So weight would be the force that the earth exerts on the book. So we're looking for the reaction pair of weight, which is the force of the earth on the book. So the reaction pair to this would be the force of the book on the earth. So it's not the force of the table on the book. It's not the normal force, because the normal force is just the force acting perpendicular. The force of the earth on the book, so that is the weight, so that can't be correct. And so the answer is D, which is the force of the book on the earth. So that's the correct answer. Okay, so a ball is thrown vertically upwards. Neglect air resistance. Which of the following statements is correct? The kinetic energy of the ball is the greatest at the highest point, essentially. So let's think about that one. Kinetic energy is Ek, which is equal to a half mv squared. So we know from one direction of motion that at the highest point, the ball is actually not moving. So at this point, v equals 0. So therefore, Ek can't be the greatest. A is not an answer. Okay. If we look at B, by the principle of conservation of energy, the total mechanical energy of the ball is constant throughout its motion. So E mech or the mechanical energy, equals EK plus EP equals half mv squared plus mgh. So from the conservation of mechanical energy, we know that in the absence of air resistance, which is stated there, that mechanical energy is actually conserved. So this statement is correct. Let's just look at the others. So by the principle of conservation of momentum, the momentum of the ball is conserved throughout its motion. So if we just look at what momentum is, we define momentum by P equals mv. So is the velocity at the bottom equal to the velocity at the top? We know that the velocity at the top is 0, but the velocity at the bottom is not 0. Therefore, this cannot be true. And if we look at the last one, the gravitational potential energy of the ball increases uniformly with time. So this may sound correct, but if we look at EP is equal to mgh. So mass is a constant, g is a constant, and the only thing we have changing is h. So the gravitational potential energy of the ball increases uniformly with height, not with time. And so this answer is not correct. Okay, looking at question 1.5. Car X is traveling at half the speed of car Y. Car X has twice the mass of car Y. The kinetic energy of car X is E. So let's work out what EK is. So EK for car X is equal to a half mass of X V of X squared, which is equal to a half. We look at the mass of X is 2m times the velocity of X is just V squared. So we have this. So E, which is this E here, is equal to mv squared. So now let's work out EK of Y equals a half m of Y V of Y squared, which is equal to a half m of Y is just m, and V of Y is 2V squared. Do not forget that this entire term is squared. If we multiply this out, we get half m 4V squared. So this is equal to 2mv squared. So now we have to write EK of Y in terms of E. So if we look closely at these, we can see that this term here is exactly the same as this term here. So what we can say is that EK of Y is equal to 2E. So our answer is A. Okay. 1 watt is defined as power when 1 joule of, okay, then we have to complete the sentence. So let's think of what a watt is. So how do we define power? Power equals work over time. So we have work, which is in joules, so we have of 1 joule. So a watt is defined as 1 joule per second, which is then not A, is not A, the energy transferred by one force is not B, energy transferred to a mass of 1 kilogram, no, but is the work done in 1 second. So we're looking at D being the correct answer. Okay, question 1.7. The diagram shows 2 point masses x and y of mass 2m and n, respectively. The third point mass z is placed on the straight line between the centers of x and y. What is the net gravitational force or strength experienced by z? When is the net gravitational strength experienced by z0? Okay, so if we just think about this, we know that for a larger mass, which is 2m, we're going to have a stronger pull. So we're going to have a much stronger pull to that mass than we do to this mass. So this mass is going to pull much weaker. So if we place Z, let's say we place Z. Okay, so the first answer is never, which is not true. So let's place Z in the middle. Okay, if we place Z in the middle, now let's see what happens. So if Z is in the middle, X has got a much stronger pull, so it's actually going to move towards X. So we can't have A or B as the answer. So let's see what happens when we place Z closer to X. So Z closer to X is somewhere there. Again, X is much stronger than Y, and so it pulls it closer. Okay, so C is not an answer. So what happens when we place Z closer to Y? So if we place Z somewhere there, what we see is that the forces on either side, this is a strong force, they're actually equal to each other, because this Z is placed at a position where the forces of Y is equal to the force applied by X. So we have the answer being D. Okay. Ohm's law only applies when the temperature of a conductor is constant. So this is just a definition. A potential difference across the conductor is constant. That's not true. The current through the conductor is constant. That's not true. The conductor is a series circuit. That's not true. It applies for parallel circuits also. Okay, the next question. The cost of using a 500 watt application for 20 minutes is X. What is the cost of electricity per kilowatt hour? So we want to know cost per kilowatt hour. And we actually know cost, which is X per watt minute from what we've been given. So we need to convert this. So X is in rands. So X rands, converting watts to kilowatt, we times 10 to the negative 3. And converting from minutes to hours, we get 20 over 60 hours. And what we end up with is the answer. We end up with 6x. If we just plug this into a calculator. Okay, and the last question. The work function of a metal is the, let's see, minimum energy needed to emit an electron. And this is simply from a definition. So I hope you guys found this useful. This is pretty much the end of the tutorial. We've gone through all the questions. I hope it is useful, and yeah.